Yeah, is it visible?
Yes, sir,
Hello?
it is visible. Yes, sir, yes, sir, it is
Fine,
visible.
First of all, I'd like to express my sincere and profound thanks to the management team, principal, and the head of the department, coordinator, recruiter faculty members for having invited me to deliver this wonderful uh, talk on deep neural network models for medical image analytics using TensorFlow in the AICTE FPP program. Since I'm coming from the industry, I would like to share my real-time experience with respect to DNN, I mean deep neural network, how those machine learning models are going to be applied in the healthcare. Especially, we will be seeing medical image analytics practically using TensorFlow. My presentation workflow moves in this direction. First, we will discuss what kind of effect machine learning, deep learning is going to play a vital role in industries, how the industries are going to be benefited, and what are the existing deep neural network models, what kind of research and innovation which is going to happen in future, how the entire deep learning technology is shaping the world. Again, in the implementation point of view, we will be using different Python packages with respect to deep learning, especially TensorFlow or PyTorch. And probably in the tomorrow session, we will see only the practical implementation. But prior to understanding that practical implementation, what I am going to show you, you need to have a foundational background behind deep learning, neural network models, and image processing, because we are going to deal with the images, medical images. So the participants are supposed to have the sufficient knowledge from deep learning and image processing and implementation point of view in terms of TensorFlow. So I will cover all these things today's session. So whomsoever is attending today's session, they will be able to follow tomorrow's session practically. Otherwise, straight away, those who are going to attend tomorrow's session, it may be difficult for them to understand that practical session without these prerequisites. That also I tell you, because I cannot repeat the same thing what I am presenting today. Fine. Then, as I said earlier, in the part of the computer vision, the way in which how we deal with different kind of activities behind healthcare, I mean medical image processing activities, okay, throughout the entire pipeline. Again, what kind of challenging DNN applications which are prevalent in industries? We will see slowly and steadily in such a way that everyone can understand. Because in the targeted audience side, there may be the beginners, there may be the intermediate level, and there may be advanced level of people. But I will cover all these things, because if I am going to show some advanced concepts immediately, sometimes it may be very difficult for the audience to follow. That's why I mix both beginners level, intermediate level, advanced level. Okay, no problem. Depending upon the audience, depending upon the understanding of the audience in terms of the communication, I mean, in terms of the question and answering, I can go up and go down. That's not going to be a problem for me. First, let us discuss what is going to happen in industries in terms of deep learning. As far as the IT industries are concerned, whether it is going to be a service industries or product industries or research oriented, most of the industries will be dealing with different industrial sectors such as retail, healthcare, transportation, education, communications, media and entertainment, technology and information services, automotive electronic systems, manufacturing, energy and utilities, oil and gas, connected vehicles, insurance, banking and financial insurance. There are many vertical industries. For these vertical industries, most of the IT companies are competing to get the projects from the clients. The moment we get the projects from the clients, because the billing is going to be done by the clients, accordingly, we in turn view those projects by decomposing into different components to the employees in our company. When you take especially the healthcare application, any big application can be decomposed into different components in terms of patient's portal and doctor side and EMR, electronic medical records, and disease diagnosis and treatments. There are so many different microservices in terms of the architecture point of view, I'm telling. Because while you are going to deal with any healthcare application, the way in which how healthcare applications were evolved for the past 25 years. What happened earlier, we had monolithic application development. Then we moved on to the multi-model view controller, MVC architecture. Presently, people are making use of microservices architecture. So in terms of the functionalities, different components will be prepared and that will be made available. There is a workflow for the particular data science or machine learning or deep learning. As you know that AI is a very big portion, first of all. Under AI only, machine learning comes. A part of the machine learning only, deep learning comes. But from the FPP name, what I understood is the big data security, something big data and security in healthcare. So even in the big data also, the separate machine learning component is available like PySpark, and that we are not going to see. But at the same time, for the same medical image processing problems or any healthcare applications, we will be having separate development and staging production environment for the big data as well as the machine learning and deep learning. And in reality, both will be combined together. There is no difference. And this is also coming under the artificial intelligence, which is closely related to the discussion of the healthcare. Next, I come to the deep neural network models. But before getting into the deep neural network models, first of all, I would like to explain the general scenario by which how the projects can be dealt, industrial projects, especially machine learning or deep learning or big data. The workflow will be common for everything. What is going to happen? Your input will be the data set. That everybody knows. Your input will be the data set. That is a starting point of AI. But now you have to think from where you are getting the data set. This is the very important question. Normally, I understand that academicians will be making use of the public data set available in the websites. For example, UCI, University of California, Irvine, there is a popular website. Whichever public data sets you are available, you are going to consider those public data sets and you are going to pre-process those data sets in such a way that the data may be readily available for the modeling. And for the general data modeling, again, you can apply any one of the learning techniques like supervised learning or unsupervised learning, or sometimes reinforcement learning will take a different path. Supervised learning, it is obvious that everybody knows classification methodology. So when we say classification methodologies, many algorithms are available, starting from Bayesian algorithm, decision tree algorithms, and supported car machine like that. But our discussion deeply concentrate on neural network. That I leave it. So one of neural network is coming under one of the classification algorithms pertaining to supervised classification. And again, similarly, we have unsupervised learning. That is a clustering that we are not looking at here. This particular session, we are going to see separate subject, separate area neural networks. Now people can think, okay, deep learning is a very new area. Where is the origin of deep learning? I tell you one important thing. The deep learning is basically dealing with neural networks, but not in the shallow layer. It is, we are going to discuss the deep layer. That differences we will see later. So deep learning is a subpart of neural network as well as AI. Neural network is a separate subject. Sometimes the students may be studying or the faculty members may be handling the subject neural networks as a elective or sometimes major subject in the PTech or MTech or whatever may be. But it is a separate subject. Like a 1,000-page international textbook you have to go through for understanding the clear-cut neural network. You don't come to the point that I am going to use only one algorithm, neural network. No, no, no. The popular algorithm may be backpropagation neural networks, but there are many different, again in the neural network, supervised neural network is there, unsupervised neural networks there. So those who are traveling with the neural networks, they may be knowing. Again, in the neural networks, Simon Higgins is a very popular textbook that you can refer. It's still, it is going to be the Bible for everyone. So I tell you one important thing. First of all, I give the justification for the title. The title is Deep Neural Network Model. First, you have to understand very deeply. And those deep neural network models, first we have to discuss for the first 45 minutes or 50 minutes. Next, medical image analytics. And separately, I have to deal with the image processing, medical image processing. What are the general workflow of the medical image processing? This is again separate subject. Everybody knows. Image processing is a very popular subject. Again, TensorFlow is coming from the implementation point of view. So what you have to understand, three different areas by which we are going to discuss. One is from pure neural network subject. Again, the extension of the neural network is deep neural network. And we have different models, that is deep learning. So deep learning is a subpart of machine learning. Since neural network is a part of the classification algorithm, it is also coming under the machine learning. This is one area. So I will spend a few minutes on deep neural networks, specifically pertaining to neural network subject as well as deep learning subject. Again, two different subjects. You have to understand like this. Neural network is a separate subject. Deep learning is a separate subject. Why I am telling all these things, those who are going to pursue wonderful research on all these problems, immediately don't jump into the particular topic without having the foundation. That we call it as a literature survey when we do research, even in the international or national level. Even in the company also, it is applicable, because in the company also, in the AI, we have a separate division. We have the development division as well as the research division. So what kind of work the research division will do, what kind of work the development division will do, and how we are going to leverage our product for our customers is going to be a very thrilling effect. Again, this will be linked with the application development, web application or mobile application development, and the entire your developed models for the given problem will be deployed in the big infrastructure like a cloud. That may be the private cloud or public cloud or hybrid cloud. So in reality, we don't take one problem, we don't write only one program, just we run it. Don't come to the conclusion like that. Because normally in academia, what happens, they deal with 2 or 3 programs and they say that this is the application and solving the problem. No. But in reality, everything will be mixed together. So one side, the data we are taking from the database, again data warehouse, or from the JSON. So again, I go to this part. As I said earlier, now all of you will come to one conclusion that, oh, SAR is saying that 3 different domains. One is neural network, again, deep learning and image processing and TensorFlow. So let us concentrate one after another. And before getting into all these separate domains, again, you have to understand the complete workflow of any machine learning project or data science project. The first important thing, as I said earlier, data is the first important point. Data is going to be taken from the public data set. That's what you people have understood. But what is happening? Normally, we won't be using public data set in industries. That is the difference. I mean, we are going to be different from academic research. So in the terms of industrial research or application development from the industries, what is happening? We will be having our own private data set. Private data set, how do we have the private data? Normally what happens, the private data set may not be revealed to the public world as far as the industry is concerned, because the entire private data set belongs to the private transactions. You can understand like this. For example, in the banking industries, financial commitments in the sense that there may be 1,000 customers, each customer may be having different accounts, and there may be credited, debited, transfer, and all those things. How these details will be revealed to the public? No. They will not be revealing. Similarly, the hospitals, no hospitals will be revealing the serious sensitive data about the patient history or patients to the public world. But at the same time, the syndromes of the patient will be known to the hospital through the software, and they will be able to do the analysis. So in industrial world, what we say that private data set, but there will be the mix of the private and public data set. Public data set actually are available for the understanding purpose of the academic research. Because if suppose the public data sets are not available, people cannot move along with that. But the private data set, now I make you to think in different way. How do we obtain the private data set? Because the starting point is data, private data set. So the private data set, for example, let me take one big hospital. For that hospital, they may be having the private different private data set with respect to different data which is obtained from different sources, various data sources. I have various data sources like databases and RDBMS and NoSQL, unstructured database, as well as the data warehouses. That's why you are studying data mining and data warehousing, and from those databases and NoSQL data warehouse. Normally, what happens? The transactional data which is taken from the database will not be considered for any analysis, because the present data we will not be taking for any analysis. Only the past data. So how do we distinguish the past data from the present data? Probably we define by ourselves. Okay, I say that the past data is nothing but last week, or past data is nothing but last month or last year. So it may be varying from industry to industry depending upon the policies of the time interval. Assume that I take the past 6 months data of the hospitals. That I move from the, normally what happens every time after finishing the transactions of the data from the database, automatically those data will be migrated to the data warehouse. Here only data warehouse is coming. Data warehouse will always be having past data. Please understand. Data warehouse is a separate subject or separate area in industry. And from the data warehouse only, we used to apply business intelligence concept. So for those who studied OLAP and multidimensional OLAP, so many concepts are there. From the data warehouse, we take the past data. Those past data we consider the private data set. I think now you understand what is a private data set. But for the understanding point of view, I also take some public data set or some other data set for your understanding purpose. I show practically later. Okay. Now, okay, somehow we receive the data from some places, and when we receive the data may not be perfect. So what we need to do, we need to check whether the data is imperfect, and redundancy we have to check, and again we are collecting the data from different sources. So we have to integrate the data that we call as the ingestion of the data. So ingestion of the data is, sometimes what happens, I can move the data from MySQL to the Hadoop. In the Hadoop itself, I can store the log data. I can do the analysis of that log data using the pig and hive programming. Again, from the pig and hive programming, after that, because hive is capable of Etl technology, after that I move it to the machine learning, and there by PySpark will be applied. This is the one kind of pathway. Another pathway, what is happening, I am taking the past data and I keep it in the separate repository. That is the data set. Now my role is to deal with the data processing, not the data modeling, data processing. So in terms of data processing, the data must be prepared properly. So what I mean by, if the data is not correct, I have to clean the data. There may be missing data. How I am going to miss the data? How I am going to fill the missing data? And Etl technology, in industry we use the word Etl technology: extraction, transformation, and loading. And we have different data transformation techniques. Why I am telling all these things? All these things are happening before the modeling. So for any big machine learning project, don't apply the model directly before pre-processing. Pre-processing is going to make a very greater role. That pre-processing, we call it as the feature engineering. Feature engineering, because when you take the data set, everybody knows that the data set will have rows and columns. It's like a matrix, some table. And every column entry, I call it as the feature. Every row entry, I call it as the sample. So I can have 1,000 samples. For each sample, assume that I have 10 records, 10 column values, 10 features. And you have to look at the value or the data type of each feature, whether it is correct or not. Sometime what happens, you will not be considering the entire data set. Depending upon your requirement, you may be selecting a few features from the given data set. So what methodology you are following to select the features from the available n features? For example, there are 200 features for your data set, and you may be interested in selecting 100 features. Now you have to think how I am eliminating those 100 features. You have to give justification. That is called as a feature engineering. So feature engineering or pre-processing will be carried out initially. That we will be seeing when we are going for the practical session. Once the pre-processing is over, now the processed data I am going to supply to any one of the algorithms. And that algorithm may be any algorithm like Bayesian decision tree, but in our discussion, we focus on the neural network. So the neural network will always be accepting numerical data. So even when you are having some other data, you have to convert it into numerical data. The moment it is going to receive the numerical data from different nodes, how it is going to process the entire node. And when you talk about neural network, there will be basically 3 layers. Input layer, hidden layer, output layer. This is a starting point for the neural network. And the input layer is capable of receiving different information from different node units, and the entire information will be passed on to the hidden layer. Something will happen in the hidden layer. Again, you are going to receive something from the output layer. And what we are going to do with respect to input layer, hidden layer, output layer is the topic of the discussion with respect to deep neural network models. And again, there is a small change from the neural network, how I am bringing the deep learning technology in the neural network. When I move ahead with the slides, you will be able to understand how you are going to understand basic fundamental neural networks from the backpropagation neural network, again deep learning. Okay, this is the way flow will be going on. Now, in the deep neural network, assume that because I cannot explain each and everything, but anyhow, I give a lot of ideas. This is not the teaching session. This is the session by which you receive a lot of ideas, and also we will see certain things and we will see the implementation. But I tell you one important thing, whichever way I show the implementation, behind the programming, there will be some mathematics. There only that kind of deeper mathematics involved in neural network only you are studying in the college through reputed professors. Probably here and there I touch, but I can't teach completely from the scratch. It's a very big subject. But unless otherwise you are very thorough in understanding foundational neural networks, it's very difficult to move ahead with any kind of deep learning models which are going to be applied on the medical image analytics using TensorFlow. Is it clear? I think now I made it clear. Now, when I'm going to move ahead with other slides, you will be able to understand. Fine. It is obvious that now you know something with respect to neural network models. Here, I am concentrating on straight away deep neural network models, convolutional layers, and subsampling layers, and fully connected layers. Sometimes certain words may be new to certain people. Don't worry, I will make it clear. Finally, at the end of the session, everybody will be able to understand everything in terms of the, as I said, beginners, intermediate, and advanced. Convolutional layers, subsampling layers, fully connected layers. Actually, in the fully connected layers only, the last area is coming. I mean, the traditional neural network is going to take place in the fully connected layers. Please understand. In the traditional neural network, what I said, and also when I'm delivering the lecture, please be attentive. And when you are going to be keen in understanding the concepts only, you'll be able to follow me. In the case of the fully connected layers, actually the input layer, hidden layer, output layer, everything is coming. Like that you understand. That is the last third layer, what I specified is the traditional neural network models. But the first 2 layers are going to be different. The first 2 layers are specifically available in the deep learning. The last layer is not new. It is taken from the foundational neural network. You understand like that. So I will be explaining one after another what we are going to do in the convolutional layers, subsampling layers, and fully connected layers. And once you have different deep neural network models, based on your experience and understanding, you can apply any one of the models or the medical image analytics, and you can implement it. Now that is now I said the deep neural network models, but one model, it's a very popular model. We call it as a Lenet model. Actually, this is the first model, Lenet, Lenet. This Lenet model was invented in 1998. So what you have to understand, I think for the past maximum 10 years or 6 years, people may be knowing deep learning, but invention point of view, discovery of the deep learning point of view, the research started even 20 years back, 1998. That you have to understand. For example, somebody is doing research now, the entire world will come to know after 5 or 10 years only, once those concepts are benchmarked in the international conferences or journals through the industries and the universities. Okay. So, what I try to tell you, in 1998 itself, the deep learning came into existence. Probably that name was not coined at that time, but after some time they brought the name. Lenet is the first model. You remember like that. Lenet is the first model. Now itself, I give one simple idea for the entire audience. Just you note down somewhere else. Design and implement Lenet. That's all. Design, all of you please note down, design and implement Lenet from the scratch. Because when I say hands-on, I have to motivate you to implement, even though the faculty members are available, you motivate your students in this direction. Again, I tell you one important thing, I may be the owner of the company or CTO of the company, but when I am going to attend any sessions taken by my employees, I will be acting as the sincere student. So what I try to tell you, irrespective of the age and experience, we should not come to the conclusion that we know everything, but we need to know many things that we have to update. Okay, that in that point, when people are those who are going to do research, we have to do many things in terms of understanding. Because the understanding of, for example, understanding of the neural network, unless otherwise you know the mathematical areas behind all those things, that and all I will come later. Without understanding your activation function, learning rate, and backpropagation algorithm, how is it possible for you to understand Lenet? You tell me, not possible. This is what I try to tell you. So, suppose, for example, the people are not aware of the backpropagation algorithm, because that is going to play a vital role throughout your deep learning. But you have to understand very seriously what is happening. I happen to stay in IIT Kharagpur for 2 years some other time. But what I understood from IIT or even international environment, irrespective of the age and experience, what they do, even student or anybody, and the people will be taking the pen and pencil for solving the problem in the notebook. And they will, suppose, for example, I am running one application. That application may be running for 1,000 iterations. But what I have to do, I take a small problem, I have to implement it. That implementation may be taking, for example, 10 iterations in the initial level, but 2 iterations, I have to do it manually in the notebook. This is very important. That's why still the students who are going to the college should really appreciate the great professors who are giving foundations on subjects like image processing, neural network, or AI, data space algorithms and all. That the students should understand, because those who are under, I don't know, research students should understand. So this is the way you can motivate the students to have the foundation, because when we are recruiting the people from the colleges also, we are not taking the latest frameworks which we are dealing in our industry. Again, our motto is to concentrate on the foundational areas only. Okay, let me illustrate very clearly Lenet. So Lekan et al. Is a researcher, 1998. When you look at this particular architecture, what you understood, as I said earlier, this is the problem of the MNIST, I mean, number recognition. Suppose alphabet recognition, when you take the particular alphabet A, the neural network has to recognize A as the A. For example, the whole artificial intelligence is evolved from the natural intelligence. We human beings have natural intelligence. And within ourselves also, unless otherwise the training is taken place, we may not be able to test properly. For example, initially when the children are studying alphabets from the schools, they understand through the teachers and parents, they understand, oh, this is A, this will be recorded. And again, the training will be taken place this A. Again, when they happen to see the A, for the test cases, they will be able to say A. This is the natural intelligence. But how it is happening in the artificial intelligence, like a neural network, how a neural network is possible for recognizing the digit, especially Leonard model. Let me take, this is the input. So A is the image. The size of the image is 32 plus 33. And what I'm going to do, this A is going to be transformed into some other form. How it is going to be transformed? That's a question. This is a convolution. This convolution again is not a new area. This is coming from the filter, which is from the image processing. Filter, you know, a lot of filters. The filters are the separate subject. We will see some example filters. So I apply the filter. I do something based on that. I receive different feature maps. Then again, I am supplying subsampling. Subsampling is nothing but the pooling layer. Pooling, P-O-O-L-I-N-G, pooling. And I do some process. I show some examples so that you can understand, oh, this is what I mean by convolution. Convolution, this is the pooling. Again, I apply convolution and pooling. And again, here only your traditional, this full connection, your traditional neural network comes. Again, input layer, hidden layer, output layer, everything comes here. In the output, you try to identify you will be able to classify the digits among the 10 numbers or 26 alphabets, whatever way. So from this diagram, what you understood, Leonard passes through convolution, pooling. Another name of subsampling is pooling. So convolution, pooling, like that is there may be different combinations. Finally, you move through the full connection and you follow the traditional process. You receive the output through the classifier. That's all. Next, when you are going to touch upon second model, because sometimes the different models, some people may be knowing earlier, some people may be knowing now itself. And these terms and all you can note down. You please put a lot of efforts to understand deeply. AlexNet. The second model is AlexNet. AlexNet for ImageNet challenge. ImageNet challenge is a very popular challenge which is hackening in US, like a hackathon. We say that even in India, Smart India hackathon is happening. Many colleges are participating, you know very well. Like that, ImageNet separately US government or US consortium of universities is conducting ImageNet challenge. In that ImageNet challenge, what is happening? Your AlexNet model first won in the year 2012 because many proposals from the different universities and the industries participated for the ImageNet challenge. Please, you go through the ImageNet challenge proposal, how the international universities are participating. Even your college can participate. Even India can participate. I hope many IITs, IICs, NIT, IIIT may be knowing this concept. Even top self-financing colleges may be knowing. Don't worry that you may not be able to participate. Even though the activity is going to happen in US, anybody can participate with the proper design implementation. AlexNet for ImageNet. So when you look at the AlexNet model in the 2012, what is happening? This kind of a complicated model we are having. Again, here the whole thing is the convolution is going to be taken place some other way. Where are the variants? Where are the changes happening? And how AlexNet is going to be different from Leonard? That you have to understand. The changes will happen in terms of the convolution and pooling. Again, the fully connected layer. Those changes, and they have brought some innovation and they were able to reduce some kind of error. So they applied, they considered different images and they dealt with different kind of image classification problem, image captioning problem. There is a popular problem called image captioning. That means when I give you a particular image wherein the cat chases the rat, probably as far as the human beings are concerned, we understand that by looking at the picture, I can say that, oh, rat is chasing the, cat is chasing the rat. But how does the machine understand? That's a question. So the machine has to understand the image. After understanding the image, it has to bring the label also. Label means the understand label. Automatically, they have to write the sentence. So how it is going to produce the sentence or label by looking at the image. So when the machine is going to look at the image, Now the image processing comes. How the machine is going to look at the image in terms of the analysis means how the objects are going to be detected, how the segmentation of the objects are going to be done, and boundary effects, all those things. Finally, captioning may be taken place, but in the context of the captioning, what happened? Both the CNN and the RNN will take place. And whatever the models we are discussing, first popular model is convolutional neural network. Actually, the LeNet and AlexNet, all these models are coming in the popular category called convolutional neural network, CNN. So implement LeNet, design and implement LeNet from the scratch means you have to implement CNN. Again, the third model is VGGNet. And actually for each model, you have a separate research paper. I think you may be having 25 pages or 30 pages. You can ask your students to study, or you can, everybody can study and understand what is happening, what are the differences. Let me concentrate on VGGNet. This is also very popular. GoogleNet is popular, ResNet is popular. So VGGNet for visual recognition. What is going to happen? The same thing. I take the image, but what is the difference from LeNet? Now, from in the LeNet, the size of the image is that it cross 32. But here, I take the image is something very big image I'm going to consider, 224 cross 224 cross 3. Again, here, first 2 times I'm applying convolution. Then I'm applying pooling. But in the traditional LeNet, first I'm applying convolution only 1 time, second pooling, again convolution, sampling. So the justification, reasoning and all, you have to understand through the research papers. Why I am doing like that? Suppose I can ask one question. First you are applying convolution 64. Next, immediately, why you should not apply max 4? Second, immediately, why convolution 64 is applied? And there has to be some justification. You have to understand. Let us see through small example. Then you will, everybody can understand what is really happening behind the convolution and pooling after some time. Because I will move with the high-level models and all first. So convolution 64. What is happening? This convolution 64 2 times, then max pool. Again, I'm increasing the size of the convolution vector matrix from 64 to 128. Why I am doing? So every time you have to put a one important question for understanding any algorithm. Why? Don't study as it is. Because when you bring any new idea, the new idea or new innovation can be brought through the extensive deeper research of the literature survey. No doubt in that. Because many doctorates are available in the meeting also. I know they will agree with me. So 64 to 128. Again, I can ask one question. Suppose second time I'm doing 128. Why I should not go to the 32 the third time? So you have to contradict with me. Why I'm not doing like that? 64 to 128, 128 to again 256, 256 to 512. Any answers from the audience? Those who have known CNN or VGGNet or in general any neural network models, what is the reason that I'm increasing the size of the con? Targeted audience, any answers? Okay, you can supply such answers even in the end of the session. Just at the end of the session, there will be Q&A just for 5 minutes. That time also you can supply the answers. You can note down now. I can proceed. So that please you start thinking, Maxwell. Finally, as I said earlier, FC is coming. FC means fully connected, 4096, and softmax is one of the beautiful classifiers. And this is the VGG model. Again, this VGGNet can be implemented by TensorFlow. TensorFlow is the package which has been invented by Google. PyTorch, again, the same DNN, deep neural network models for medical image analytics could be done through another programming framework, PyTorch, which has been brought by Facebook. And Caffe, again, note down one question. The end, you please supply the answer. Anybody else? Caffe, who has brought Caffe model? Caffe is like TensorFlow. Caffe is like TensorFlow. Again, MXNet is there. Who has brought MXNet? So you please note down. The end, I will be asking again. Caffe, like a quiz. You can note down like that. Caffe and the MXNet. So something I'm doing convolution alternatively. Again, pooling I'm doing alternatively. Why I'm doing like that? That's a question. So now let me take convolutional network. In the convolutional network, what's happening? Every layer of the ConNet has the same API and takes a 3D volume of numbers, output a 3D volume of numbers. Constraint function must be differentiable. So I take one image, 224 cross 224 cross 3. Every image will be having depth and weight and height. And finally, I'm bringing some kind of probability analysis. I'm bringing down to the 1 cross 1 cross 1000. Even in the fully connected layer, once you have applied convolution and pooling, you reach to the fully connected layer. And I apply the matrix of 7 cross 7, 512 in the max pool. In the fully connected 1 cross 1 cross 4096 neurons. And these 2 points you are going to apply in the fully connected layer because this is the activation function. First, initially, those who are known the fundamental neural networks, they will be agreeing with me. This concept you have to do. This B is bias, W is weight, and X is the input vector, and F is the function. Again, you apply some thresholding. You can apply any kind of thresholding to yield the result of the classifier. And this is the convolutional layer. Again, okay, a few slides I have taken from the Stanford University coursework. And this is the convolutional, okay, 64. This is the actual image, 224. 224, depth is 3, D equal to 3. Please remember, whatever I'm saying, again, at some point, I will even go down very deeply. This is the depth. Depth is 3. Again, 224, 224, again, cross 64 can be implemented efficiently with the convolutions. That's all. Again, pooling layer. I am doing max pooling, 224 cross 224 cross 64. This is the, you understand in this way. You take one image, which is of size 224 cross 224 64. I apply the pooling. Because of that, it is going to be reduced to 112, 112, 64. So pooling will be applied whenever I'm going to reduce the size of the image without losing the originality of the image. That you have to understand. Performs downsampling. Okay, reducing the size of the matrix. That's why I call it as a downsampling. And this is what downsampling. This is the image 224. Apply the downsampling. It has been reduced to the 112, 112. The diagram looks like this. Now you can understand very simply max pooling layer. So this is the image. Somewhere else I used max pooling. In the architecture, if you look at the architecture, this is the max pooling. So let me give clear example of the max pooling. So when you teach your students, especially professors, go down, teach max, actually, mathematics for understanding neural networks, how it is going to work. Suppose a LeNet, the students should be capable of solving the problem, okay, using pen and pencil, as I said earlier, if it is possible. Possibly, I think people will be agreeing with me. Those who are going to solve backpropagation neural network for just 2 iterations, can you make a guess how much time will it take for the particular student to finish by hand calculation? Just to note down. At the end, I need answer. At least like 2 iterations. So practically, because even every computer science engineering subjects, it's not a theoretical subject, actually, please understand. Every subject is a mathematical oriented subject. When you teach any subject through maths, the students will be very happy because maths, they like it and they understand very clearly also instead of telling theoretically. Now, let me tell like this. This is the max pooling. I take this matrix. What is the size of the matrix? 4 cross 4. Okay. When I apply the max pooling, it's very simple. I'm dividing the matrix into 4 areas. The first quadrant, I'm taking the maximum value. That's all. 1, 1, 5, 6. I take the value 6. This is 8. This is 3. This is 4. This is the output of the max pooling. Okay. Now what you have to do? You have to make your students to write a separate module. Write a Python program to implement max pooling separately. Don't ask the student to implement LeNet first. Because when they come for the interview also, we will be going in that direction only. Because nowadays what's happening in the GitHub, projects are available, code is available. They download the code, they execute, but they are not able to explain. When they come for the interview and they fail, they get into the big company. So what's happening? They write a Python program to implement max pooling from the scratch. So the input of the image is this one, and write a small function. That function should divide the entire image into 4 portions. It has to traverse through the matrix, and for each sub portion, it has to select the maximum number. That is the implementation, and that the student should write by themselves from the scratch. Max pooling, like that average pooling. Average pooling means you take these 4 values, you take the average value, you write down here. Like this. Now, I think I made it clear with respect to max pooling. Similarly, I will make it clear convolution later through again small example, because higher level now we are moving through the slides. Now, features learning. Features learning, features, I already introduced the word. Feature engineering will be taken place in the first phase of any machine learning project. And what do the neurons learn? Low level feature, mid level feature, high level feature, trainable classifier. This is what really happening when you are going to pass any image to any one of the models. Let it be LeNet or AlexNet or VGGNet or GoogleNet. GoogleNet has been invented by Google. Who invented ResNet? RESNET, ResNet. Please note down. Those who do not know, tell me the answer at the end. I'm passing a lot of questions. Probably in the end, some people may be supplying answer to the chat box and all. And because it's an online session, sometimes I can ask the participant to discuss. I don't know whether the organizer has muted or unmuted with respect to the audience side. Anyhow, I move. So low level feature, mid level feature, high level features, all these features will be considered for the trainable classifier. That's why you apply the convolution and pooling consecutively till you reach the final layer. Final layer means fully connected layer. Fully connected layer means, what is the interpretation? All the neurons, all the units from the input layer should be connected to all the neurons in the hidden layer. Similarly, all the neurons from the hidden layer should be connected to all the neurons in the output layer. That is a fully connected network. This is what really happening in the image classification problem. For example, medical images classification problem. Suppose, let me take a lot of medical images. Okay. In terms of, suppose I concentrate on with respect to breast cancer image or Parkinson's disease. Many popular problems are available. What you have to do with respect to the classification or with respect to the benign or malignant, what is happening, or with respect to the characteristics of the image, first you can classify. This is the classification. Suppose a good, for example, in the breast cancer analysis, whether the cancer is existing or not. That is a 2 classification problem. But this problem is called as multi-classification problem. I take a set of vehicles, and all those vehicle images, I pass it on to the any one of the CNN models, deep neural network models. Finally, I may be able to classify under different class labels. I hope class labels is the output classifier. It may be truck, car, airplane, ship, and horse. The same workflow which is applied in the vehicle analysis that may also be applied in the medical analysis. Here, what I try to say, I take only one image. It may be, I think, truck. A truck, because it is showing the green. It's a most possible nearest case. So truck is the exact answer. Next, car. So when you take the truck, as a human being, I know the machine how it is going to classify this truck as the truck. So it is by applying convolution, I have different pieces like this. Then again, this ReLU. ReLU is nothing but in between convolution, I apply the activation function. The activation function will be applied in the design and the implementation of the neural network, ReLU, like a sigmoid activation function. Then again, ReLU. ReLU is applied in between convolution, pool, alternatively together. Again, you should ask question by yourself, why you are applying? What is the difference? How ReLU activation function is going to be better than the sigmoid activation function or tanh activation function? So, for example, when I'm going to show the demo of this kind of vehicle problem or medical analysis problem tomorrow, now whatever technical terms I am saying, the concepts I am saying, and packages I'm going to say further, you will be able to follow easily. Without understanding all these things, immediately I show one big program or 2 or 3 programs in terms of application when I'm going to run, it's very difficult for you to comprehend. So basically, till now, you have to come to the conclusion like that. LeNet layer, what operations I have done? Because when I am going to, for example, let me, in my application, which I'm going to show tomorrow, let's assume that I'm going to apply LeNet or AlexNet or VGGNet. When I'm going to apply LeNet on any medical image analysis, in those functions, those classes, because in terms of the object orientation only, normally people will be developing applications. not using the straight away functions. In terms of implementation, I am talking in between because I mix both. Actually, I mix concepts as a little bit max and the implementation because from the industry side, everything is required. I cannot omit. Okay. When you look at different operations, each operation can be placed under separate functions, or certain function can be combined under particular class, because when you say the class, the object will be created. It is an instance of the class, and the object will be considering the data member and the member functions in terms of the C++ or Java or Python and all. So like that, you first what the student should understand: what is meant by convolution? What is the mathematical background to begin convolution? How do we implement as a separate exercise? Then again, separately, you have to understand each and everything. Then you have to combine together, make this again from the scratch. Again, how you are applying the entire tenant layer onto the real-time application. So convolution, separate function, max pooling, activation, flattening. What we will be doing, the multi-dimensional vector will be reshaped into one-dimensional vector. That is the flattening. Tanh is the activation function, like ReLU or sigmoid. Sigmoid is the very famous one. Traditional activation function applied to the backpropagation. And when you discuss any neural network, it is very obvious that there will be two phases. One is forward propagation, another one is backward propagation. And in the forward propagation, what happens? You are going to apply your input from the input layer, hidden layer, then output layer. And finally, in the output layer, you will not be getting the result immediately. And you will be getting some output. That means normally people understand the taxonomy of the classification, and you are expecting something and you are computing something. Okay, computed output and expected output. For example, your expected output is 1. Your computed output through the network, input layer, hidden layer, output layer is 0.7. So there is a difference from the computed output from the expected output. So the expected, if there is a difference between expected output and computed output, that I called as an error. That error has to be reduced. For reducing the error, again I'm going to travel from the output layer to the input layer via hidden layer. There only I'm applying the backpropagation algorithm for reducing the error. Okay. Again, softmax is the classifier. So softmax is the classifier. This classifier, again, as I said earlier, without max, you can't understand any artificial intelligence areas or machine learning, data science, even big data, because especially in the big data, your Hive or Pig, your SQL will be coming. SQL processing will be coming in terms of the joins and all. But when you are going for the PySpark, that is also another kind of machine learning framework like TensorFlow or PyTorch. Again, people may be thinking, why I need to have different multiple programming frameworks? Which one I'll be using really in the industry? It depends upon the use cases. It depends upon the requirements of the application. In reality, we'll be having the big infrastructure for implementing. Now people may be thinking, sir, I am already having a lot of classifiers. Even earlier, I think from the academic world, I know that something 10 years back or 15 years back, I think there was one tool called Weka tool. Using that Weka tool, they'll be applying the data set onto the Weka tool, they'll be taking the output, algorithm they'll be selected, readily available open source tool. That is different. And even for the past 20 years, we do all this classifier and clustering. And why there is a immediate drift in terms of the big data and deep learning? Any understanding from the targeted audience? Even sir, organizer, you can permit even targeted audience for 1 or 2 minutes for the question so far I asked. Why we need to deal with the TensorFlow and PyTorch or PySpark? What is really happening? I request the organizer to allow the audience to speak if they are ready to speak. Just 2 minutes. Sometimes what's happening, always with the direct mode, we will be, I am the very interactive person, but unfortunately in the online session, it's not possible. But anyhow, we try our level best. Any questions? Someone, I would like to hear somebody's voice.
Yes, sir.
Yeah. Any one of the target audience tell me the answer for this question. Why we go for TensorFlow, PyTorch, or PySpark, such advanced frameworks, even though we are having already certain existing Python packages, or whatever questions we discussed earlier. I asked a lot of questions here and there.
We have to pick the accuracy in correct manner.
Oh,
So only we are going to Python, I think so, sir.
1 minute. Can you repeat? Very good. First of all, I appreciate the audience for coming forward to supply answer. Once again, repeat.
To need to get a correct accuracy, higher accuracy, so only we have to go to Python, sir.
But I asked one question. Everybody will be telling this answer. I agree with you. But what is happening in research, with respect to our own research work, every will be bringing 99% accuracy for the past 10 years research paper, which is correct. Everybody is saying that my algorithm is correct. I am bringing 100% accuracy for the published paper.
Yes, sir.
The question is why you are going for the deep learning frameworks, even though you are already having the data mining and machine learning earlier. Actually, prior to 6 years, also people were dealing with machine learning projects, data mining projects. Why there is a sudden drift? Yeah.
Yes, sir. Machine learning produces a less amount of accuracy compared to deep learning, but deep learning have a more time delay. This is only the difference, I think.
This answer, I agree with you. But normally, what happens? Any researcher with all the research scholars will be able to bring 98% accuracy in all the published papers, even for the past 25 years. So what is really happening? Yeah. Anybody else? Any other person? I really appreciate. I give the answer finally. Yeah, very good. I think Meenal from which college?
Convolutional College of Engineering and Technology.
Good. I think that I'm making the people to interact with me. This is because sometimes what happens, one-way communication may not be good. Okay. Any other audience? Because I was talking for 1 hour. At least if I receive some answers from some audience, I will be very happy. Yeah. Any other answer from target audience with respect to such questions? And I put a lot of questions also in between. That also you can tell me answers for the question which I put earlier. Just for 2 to 3 minutes, then again proceed. Please come forward. Targeted audience.
Sir, am I audible, sir?
Yeah, fine, audible. Yeah, please.
Sir, when we take any data set put into any ready-made tools, so you get a...
1 minute. Before that, you please introduce yourself, sir. Doctor?
Sir, I am Dr. J.M. Dayashankar from Sri Ramakrishna Mission Vidyalaya, sir.
Okay, great. From which place?
Coimbatore, sir.
Okay. Please proceed.
Sir, when we get a data set and you put it into any tool, whether it is Vega or Orange, whatever tool it is.
Okay.
So you get a colorful image or whatever data you get it.
Correct.
Yeah. It is not exactly the research. It is a tiny part of the research.
Yes. That's why I asked this question to all of you.
Yeah. That is
because 1 minute, all the participants are reputed faculty members, so we are exchanging our ideas to discussion. Yes, please proceed.
Yeah, it is way beyond that. You have, so that's why we are moving into.
Okay, still I didn't get the answer. Again, generic answer. Okay, let me tell the reality behind the new frameworks, why the industries have brought. The whole effect is, even though we had powerful algorithms earlier, when you look at the PySpark or TensorFlow or PyTorch, which are better than, or deep learning, especially deep learning, or even big data, parallel. Actually, what is really happening, Vega will be dealing with the sequential machine learning. In the machine learning itself, there are 2 different areas. If you go in depth, you will be knowing sequential and parallel machine learning. Actually, the deep learning deals with the parallel machine learning. Parallel machine learning in the sense that, for example, I take one data set and I pre-process. Even with respect to pre-process, everything will happen in parallel. Again, with respect to data modeling also, as you think in reality, the entire problem will not be solved by one server. Parallel means what? Parallel system, parallel and distributed systems. There is a separate subject in computer science. Parallel and distributed systems. In parallel and distributed systems, we mingle with the AI. Actually, that is a reality. In parallel and distributed systems, we make use of a concept called cluster. That cluster, probably I can take 20 machines or 30 machines, 30 node cluster. In CMU and all, Carnegie Mellon University and all, 100 node cluster, 1000 node cluster, and like that, I can have different clusters in different geographical locations in the data centers. Let me take a small example. Let me take one cluster which is having 8 machines. And in fact, through this lecture, through this talk, what I would like to tell you, I passed one information to all the colleges. Please set up cluster in your department. Because when I happen to visit many even popular colleges, Central colleges, most of the colleges are not having clusters, except 1 or 2. Clusters means when I'm visiting your department, I'm looking at your lab. That lab is supposed to have the big clusters, not like industrial environment, at least small clusters. There you have to apply your projects, ML projects and DL projects. And what is the advantage of this cluster? I tell you, there will be one master machine, then slave machine, worker nodes. Normally we call it as the worker nodes and master nodes. And your any deep learning project or machine learning project or big data projects will be applied will be sent to the master node, and it will be partitioning the entire work into different nodes, and the entire task will be handled in parallel. This is what really happening through MapReduce. Probably I think yesterday afternoon you happened to go through, because I happened to see the schedule. MapReduce or Hadoop, HDFS, everything is happening parallel implementation only. Such parallel implementation. I mean, again, at this juncture, I introduce another subject called parallel algorithms. Because nowadays the students are not having an opportunity to study these parallel algorithms. People think that parallel algorithms are the old subject. No. In the industry, we bring parallel and distributed algorithms, parallel and distributed environment set up for AI and big data and machine learning, deep learning. That you have to understand for the real implementation. So in the master-slave environment, your data set, private data set, and will be applied again the algorithm, because your neural network itself is a parallel processing unit, not a sequential processing. Please understand why I am applying neural network in the parallel learning, parallel machine learning. I am not I'm not considering Bayesian for the deep learning. But at the same time, I'm considering the neural network for the deep learning. Why? Because the neural network itself inherently capable of dealing with the parallel processing. That's why it is suitable for. So what you have to understand through this delivery, the parallel, because most of the people think that through my laptop, I apply one algorithm, one problem application I take, through the algorithm, I get the output, I put it accuracy 90%. Are you getting accuracy through your cluster? No. That's why even though you do real research work through your mathematical background, implementation point of view, most of the research papers are sometimes are weak in nature because of the implementation. But in the foreign research or certain, suppose IIT and IISc, they really apply into the parallel implementation only. So through the cluster, because the final result, everybody will be having accuracy 100%. But how do you get the 100% is the important question. Somehow you are writing the paper without doing anything, means it's not a research. Nobody will be accepting. That paper is the paper. But the question is what I try to tell you, the parallel cluster, do you have in your environment? Or are you using your remote cloud? Yes, the AWS cloud or Google Cloud Platform or Amazon or Azure or Rackspace and IBM, all those things. Suppose those things may be expensive, I agree with you. But when you are going to set up your laboratory within your college, you can write a proposal for the funding, or sometimes you can get the funding from your own college internally, set up the cluster, then in the cluster, you run these applications, then you will be knowing the power of deep learning. That's why I would like to tell you. Okay, due to the shortage of time, again, I rush it up. Now what's happening? As I said earlier, you know a lot of operations for the Linux layer. I hope I make it clear. I go slowly and steadily. Everybody understands different terms. And softmax is a classifier. Automatically, you please understand. In this particular area, even any areas of any practical implementation, I cannot escape from mathematics. Okay. But I don't want to teach maths now, but at the same time, I show certain things. That is also important, that is included in the implementation of the real-time application. So probability is there. So prediction, you do the prediction, so the probability of Y equal to I given X, W is the vector, bias, all these things you know, and use the loss function. So such a explanation, the students should derive from the reputed professors. And log likelihood functions you people are applying. And again, negative log likelihood, all these things you know. Now, what I am trying to tell you, since the deep learning DNN models are dealing with the convolutional layer, pooling layer, the third layer is fully connected layer. In the case of fully connected layer, as I said earlier, now you touch upon the neural networks. I mean traditional neural networks. So your data set automatically, actually in the initial stage itself, you are applying data set. In the case of the convolution itself. Again, samples, you know, features, training and testing. Training and testing will be taken place in neural network. Now, let me take, again, just 5 to 10 minutes, I show the complexity level in understanding neural networks. That's very important because I again I tell you, without having the strong background, especially researchers, MTech or researchers or BTech, and without having a strong foundation from the fundamental neural networks, don't get into the advanced generative adversarial networks, GAN or any kind of CNN models. It's very, very difficult to understand. You may not be able to comprehend from the IEEE transactions and the very popular journals and popular conferences. Okay. Just to 5 minutes, those who are going to the beginners or intermediate level, I am explaining like this. Some people may be knowing. Just anyhow, my explanation may be different in a different direction. This is what is this? This is the fully connected layer. In the fully connected layer, I take quickly I explain, 3 nodes for understanding purpose, 2 units in the hidden layer, 1 unit in the output layer. But this is not the real case. Real-time application, input layer may be having lot of units, hidden layer may be lot of units, output layer may be multi-classification problem. This is the 2-way classification problem. But understanding what you have to do, a fully connected graph, the 1 is connected to 4 and 5, and 2 is connected to 4 and 5, 3 is connected to 4 and 5, fully connected. And I'm applying weights over 1 and 4. So W14, W15, W24, W25, W. So I have some values. This is the way first you have to calculate in the notebook. Okay. As far as this problem is concerned, I am taking only 3 inputs, 3 values, 1, 0, 1. But in reality, what is happening? Suppose, for example, I take an image of 32 cross 32 cross 32, something like that, 32 cross 32 cross 32. You multiply all the pixels, you count. So for example, let me say 5,000 pixels are coming now, 5,000 units will be coming for a particular image. So for a single image, those number of pixels will be coming. So practically you cannot visualize the 3D diagram. So, but for the understanding, this is the thing which is happening in the college level, but the students should pay careful attention to the wonderful mathematical class associated with the neural network by the teachers who should respect teachers. I mean students, X1 and X2, X3, and I pass 101, 101. Let me take some weight values. So here, how many weight values? Because 1 node, 2 nodes, W14, W15, W25, W1415, W2425, 3435, 4656, and these are the theta no biases, theta 4, theta 5, theta 6, and for making the stability of the neural network, the entire neural network. Now you have to understand how the backpropagation algorithm works. Okay, because if you do not know the working style of the backpropagation algorithm, you cannot understand the implementation part. Probably I will explain later the backpropagation, because tomorrow when I am going to show the hands-on, that hands-on I have to actually explain the algorithm. So that algorithm tomorrow I explain the BPN or CNN, whichever is crossing. But today just I make my audience to be comfortable with my journey. That's all. Okay, you take such values, you do something and you apply based on that Lenet algorithm, Lenet basic operations and AlexNet operations or GoogleNet, and I apply those model onto the medical images, image processing. I mean, medical images. Again, image processing is there. And also till now, I have not brought the second big area, image processing. And I think CSC and EC students will be studying image processing is a major subject, elective subject. Please pay careful attention to that subject. Very, very important subject in terms of the AI world. And also more demand is there presently. Image processing, similarly, natural language processing in terms of text analytics. Similarly, speech recognition inside of the sound analysis, okay, speech analysis. So video analysis or image analysis or text analysis, NLP is a separate subject. CSC students will be studying it. So all these things you have to understand for modeling any kind of problem. Certain slides I skipped, and because why I brought all these things, all such background information are required to have the hands-on on deep neural network models for medical image analytics using TensorFlow. So weights in neural networks. So this is the activation function, just 1 by 1 plus e power minus x. This is the sigmoid activation function. You apply the x value over here, you will be getting this. And these slides have been taken from Coursera, from the Stanford University. And the neural network feed forward, again, this is the bias unit, layer 1, layer 2, layer 3, you do the computation. And input layer units are features, as I said earlier, one hot vector or word embedding. Because when you have the input, and the input matrix should be represented in some form. This one hot vector or word embedding. This word embedding is a very big area coming from NLP. Again, behind that word embedding, big mathematical problems are there. And you will be doing weighted sum of the input. That's what you are doing. Okay. Again, activation function. Weighted sum of the input is this one, fx plus b. So fx, that is weighted sum of it. And activation function is the non-linear function. And so when you do so, when you have different units, you do all the independent multiplication and all. And basically what you have to understand, for example, I happen to show you one graph that you remember always, basically 1, 2, 3, 4, 5, 6. So if I want to compute the input unit of the 4, what I'm going to do, I am taking the value output of the 1 and weight, output of the 2 and weight, output of the 3 and weight. I am multiplying and adding, I pass it on to the input of the 4. That's all. That you multiply like this. So one is the output of the first unit and the weight value. I am passing on the edge. So you multiply, then add it on to the bias. So such vector representation is important even for the deep learning, and forward propagation is going to be taken place. And now, when there is going to be the error in the output part, I already said that when the error will happen when there is a difference between expected output and the computed output. So in order to reduce the error, back propagation, you do the computation part of the gradient. This gradient will be dealing with the differential calculus. I don't want to go deeply. I think you have to understand this, but this is very important. I think some, especially in the deep learning lectures, all these things may be studying separately. Gradient function. And you have to do like that, how I am computing this gradient, which is dealing with a differential calculus. Okay, for the time being, I can tell like this. And again, once you have applied the CNN model, whether Lenet or AlexNet or what I say, VGGNet or GoogleNet or ResNet, like backpropagation neural network, algorithm is producing the output. There is a error, again backward propagation. So many iterations will be running, keeps on, the algorithms keeps on running with multiple iterations to reach the targeted label. Okay, now again the classification accuracy, as the participant said, you will be able to find the accuracy, performance of the accuracy in terms of the precision, recall, and so many true positive, true negative, false positive, false negative, all those things you'll be finding out. I agree with you. But how do you tune your parameter? This is a very another important area in any deep learning. Hyperparameter tuning in neural network. That means, suppose for example, you have the input of the images, but you have weights. Accordingly, you get some output. That is the error. But in the before getting the output error, before getting the error in the first iteration itself, if you change the values of the weight, okay, the iterations may be reduced. So the question is, how do you initialize the weights? Initialization of the weights is very important. Sometimes research purpose, what do you do? This initialization of the weights itself is a separate research area that can be done through genetic algorithm. Presently, people may be thinking, I really appreciate both academic and industrial world, because academic on left hand side means industry on the right hand side. Both should travel equivalently. Okay, this is very, very important. That's why we have to consider both equivalently. Okay, academics as well as industry. Why I am telling, suppose for example, if there is no innovation, okay, from the basic any concept, okay, there will be no advanced framework. This initialization of the weights could be found through the genetic algorithm. Just I am giving the clue. But the way in which how you update the weights, weight updation, bias updation, this is one separate area. Second, you have to select the activation functions and optimization algorithms. The third, optimization algorithms are dealing with the backpropagation. Okay, here only the optimization algorithms will be coming along with the backpropagation and regularization. Regularization is going to deal with the overfitting of the data and underfitting of the data. Practically, we will look at when the overfitting will happen, when the underfitting will happen with respect to certain machine learning models. Tomorrow, everything will be based on the programming, even from the starting session itself. First, because today completely explain the concept such a way that everybody can understand. Tomorrow, I only move through the coding and I explain, and wherever explanation is required, again I show some slides. I will go. So tomorrow session, please you attend seriously. So you'll be having some kind of different knowledge through deep learning. So regularization is a very important concept through which you can deal with the overfitting and underfitting of the concept. And learning rate scheduling. For example, there is an important concept, learning rate in the neural network setup itself. I can take a lambda or alpha equal to 0.7 initially. Sometimes I can increase the learning rate. Sometimes I can decrease the learning rate. Sometimes I can write a separate function which can trigger the different values of the learning rate that I call it the learning rate scheduling. Learning rate scheduling, LRS module or regularization module or optimization, activation function, and weight updation. All the 5 different big areas are available in the hyperparameter tuning while you are going to deal with any experimentation. And again, in the experimentation, just I go one after another. Suppose what are the steps you are going to deal with the initialization of the weights? Are you initialize the weights just like that? I mean, through the randomization function? Yes. Normally, what happens? Any weight initialization, I can use a normal distribution from the statistical distribution, binomial, Poisson, normal distribution, or uniform distribution. These and all you have to set up. That's why I'm saying implementation is going to play a vital role as far as industry is concerned. Rather than concepts is good, but again we'll be concentrating on the implementation with the innovation of the algorithms, normal distribution and the uniform distribution. So while you are asking your students to write a program, don't ask the students to apply weights immediately. Why they should not apply normal distribution, uniform distribution to initialize the weights automatically through separate functions. Again, a different activation function, selection of activation function. For example, I'm running one application using a CNN model like Lenet or AlexNet, but at the same time, I may be using any one of the activation function like ReLU. But always in research, what is happening, industrial research, what is happening, the way in which how you apply different activation functions, and you have to see the sensitivity analysis. If I am selecting TANH, what happens for the same algorithm? So assume like this, I have 20 parameters, but I am changing only one parameter activation function. So you keep one parameter constant, if there are 10 parameters, you keep 9 parameters constant, one parameter you have to change. This is the logic, okay, in the industrial settings. So 9 parameters constant, one parameter you change. If that one parameter, if it is going to be activation function, and if you deal with the ReLU, what is happening? You take one result. Again, you change this ReLU by ELU. You take another result. You apply TANH, you take another result, because the iterations may be increasing or decreasing, accuracy may be increasing or decreasing. So this is what we are saying, that experimentation. In reality, what is happening, suppose when we take the big models for any real-time application using GPU clusters, in the GPU cloud or Azure cloud or any AWS cloud, on-premise data center or remote cloud, what is happening? As you think, it's not simpler. Sometimes the models may be running for 1 week or 3 days or 4 days. So it will be, even the models will be running. Models will be running for your big data set for 5 days. Then only you can get the output. In between night we will be making the machine. I mean, some people will be there and they will monitor the intermediate results. That is the reality happening through the cluster setup. All those things, logs will be taken place in between, and those will be recorded in the Hadoop machines. And again, in the case of optimization algorithms, I tell you one important thing: those who are going to be the deep learners, I mean deep learning research people, those who are dealing with advanced areas of deep learning, I hope they will be able to understand all these things. This is the optimization, stochastic gradient descent. Again, momentum, autograph. Hello? Any disturb? Anything? Okay. Now SGD stochastic gradient descent, because I tell you the variants of the optimization algorithms what you can apply. So SGD or momentum or ADA grad or ADA delta, RMS prop, ADAM, and out of these 6 different algorithms, you can apply any one of the algorithms. And to understand each and every algorithm, again you have to deal with the big mathematics. Okay, and in the backpropagation standard is SGD. But if you change it to momentum, ADA grad, ADA delta, because this, I tell you, this optimization algorithm itself, one can explain for all the 6 algorithms for the particular day by taking 4 sessions. So that kind of details are available, but I am telling everything in the exclusive and the expanded view. Again, you will be doing, you will be computing the loss function for the stochastic gradient descent. And in the regularization, there are 2 categories: L1 regularization, L2 regularization, and the stochastic gradient descent. And here you understand that this alpha is the learning rate. You do the updation, current updation, the way in which how weights are going to be updated and bias are going to be updated. And in the case of regularization, L1 regularization, L2 regularization, both, again, you please apply the sensitivity analysis. You look at the overfitting and underfitting, what is going to happen, and find out the differences. And the learning rate scheduling, change the values of the learning rate in terms of hyperparameter tuning, low, high, optimal. So what is going to happen with respect to the experimentation purpose? Because all these things, when I am going to show the tomorrow's hands-on application, there is a chance for you to see everything I am showing here. I may be changing the learning rate as low, high, optimal. That time, the application will be running in the different style. We will be having different iterations. So the bigger topic is optimizing the neural network, the optimization of the neural network, and you have to compute the Jacobian matrix and all those details are available. And these are the deep CNN perspective. And as I said earlier, ReLU activation functions there, norm layers of the data augmentation. Data augmentation means what is going to happen? We can change the different set of images, and there are certain dropout vectors, dropout neurons in the implementation, design and implementation of the deep learning. And when you have any kind of images, you will not be dealing with all the images immediately. You may be decomposing the images into different batches, and each batch will be having different size, batch size. Batch wise, you will be running the entire algorithm. Momentum, learning rate, just I am giving one specification. Oh, when the dropout is going to be 0.5, what is going to happen? Batch size 128, SGD 0.9, learning rate. So similarly, you can change a different set of values for different specification. So what this we call it as a test case. So the test case 1 is going to be test case 2. You change the different values of the parameter, test case 2, test case 3. Like that, you have to prepare your test cases. You have to execute. You have to see the results of the different test cases by setting up the development environment, and you'll be able to evaluate the whole performance of the entire deep CNN over the medical image analysis. But till now, I have not touched upon the medical image analysis. Now I'll be going to touch upon medical image processing. Separately, I am telling, then I will mix together. Like this, lot of parameters are there. Next, now I'm mixing these two. I mean, as I said earlier, there are three components. One is deep neural networks, medical image analytics. The third one is implementation, TensorFlow. What I would like to tell you, first I will deal with the implementation parts, to some extent. Again, finally, I can tell you the operations, what kind of operations are happening behind the medical image processing. So you have the background of all these three. Then we will mix all these three for the real hands-on. Now, in the case of applying TensorFlow onto the deep neural networks, you are not going to understand TensorFlow program. This is a separate programming. First, this is a programming side, TensorFlow programming. You have to deal with the different sensors, but when you happen to look at any big deep neural network applications, you may be having different Python packages which may be imported. Similarly, when you are going to use R programming for the machine learning, that is totally different. Now we consider the Python. NumPy. NumPy is the package which is going to deal with the image, array processing, multi-dimensional array processing. Then Pandas. Anybody else? Can you tell me where do we use Pandas in the analysis of medical image processing, medical image analysis? Where do we use Pandas in the medical image analytics? Audience, just 2 minutes. I listed out the different packages. Pandas, sklearn, OpenCV, Keras, TensorFlow, Matplotlib. For all these packages, from the audience side, whomsoever knows, can you supply answers quickly? Because many people may be attending different industrial lectures as well as you may be doing research. Just I need answers from your end. Yes. Please, organizer, permit the audience to speak for just 2 minutes, 2 to 3 minutes. Then I can. Where do we use Pandas?
Sir.
Yeah. Where do we use Pandas for medical image analytics? Any guess? The answer may be wrong, no problem.
If participants, you have permission to unmute yourself. So you can unmute and ask. If participants, you have permission to unmute your mic. So that you can.
I think 87 participants are there from the. Okay. Where do we use Pandas? I think I give one clue. Suppose for any big machine learning project, there is a separate flow. Initially, I was explaining. First step, data pre-processing, then data modeling, then data visualization. So like that, the three major big components. Where do you use Pandas? I'm giving clue. Hello? Because without using Pandas, you cannot develop any real-time machine learning projects. That is true. Where do you use? Okay, I give clue like this. Suppose if you are using the laptop, you put Pandas in the Google, find the answer. Now you tell me. You try to correlate with my lecture. No problem. Where do you use Pandas? Where do you use sklearn? And in which scenario OpenCV will be applied and Keras will be applied, Matplotlib will be applied. Among all the 2, 4, 6, 7 packages. I hope you people must have known, because these are the things that have been available for past 20 years actually. Probably TensorFlow may be new. TensorFlow, PyTorch. Other things are not.
Sir, OpenCV can be used for image processing applications.
Oh, okay, great. First, I appreciate, very good. OpenCV. Like, again, suppose I am asking you, you should not use OpenCV for the image processing. But there are certain image processing libraries that are available other than OpenCV. What are the libraries? I think one person was talking to me. If you know, you tell me. And again, MATLAB people are using within academics. You ask the students to use MATLAB, but The student should make use of Python effectively for getting the job or to get into the industry. Python or R program. Okay, sklearn. Any answers? OpenCV, great. Image processing, sklearn. Just 1 minute. Sometimes in between I need a pause so that I can understand, okay, where the audience are. I'm surprised. I'm getting surprised. Really, people are not aware of pandas. Please type pandas in the Google. Tell me. Matplotlib, where do you use? Please be interactive.
I think so for plotting graphs or images.
Ah, great, great, great. I think from which institution? One
This
faculty?
Anambra University.
Faculty?
Engineering faculty.
Okay, okay, nice, nice. Okay, okay. Matplotlib for visualization, great. Other than Matplotlib, any other packages will be using? Now, why I am interacting like this? There is an answer behind it. There is a reason behind it. Please understand. The reputed faculty members should understand certain things. From the industry side, when we deliver such a latest framework, some packages and all, noting down, and again, you take some practice, at least to some extent, you motivate your students to do. Then otherwise, how the students will be able to travel along with all these packages and how you can evaluate for their own mini projects and all. This is a big problem. Okay, that's why we are telling. No issue. Matplotlib, okay, anyhow, somehow I received the answers, 2 answers from audience. One is Matplotlib for visualization, and pandas, pandas until now I not got it. OpenCV for image processing. Pandas and sklearn, again 1 more minute. I can wait, no problem. No hurry. Just any one of you type it in the Google and tell me. Okay, what is the difference between sklearn and TensorFlow? Or what is the difference between sklearn and Keras? I think many AICT FDPs are going on with respect to big data analytics, AI and big data. So people might be having practical knowledge. I hope so. Any answers? Okay, I will proceed with that.
So there is
So
an answer in chat.
yeah.
Sir.
Oh, chatbot. Oh, I'm getting an answer from chatbot. Oh,
Yes, sir.
that I
Please
didn't
check it,
see.
sir.
1 second. 1 second. If it is, I'm very happy. Classification, which one is better, sir? Oh, that also I can see now. Class, which one is better, sir? For data analysis. A good collection of data analysis. Very nice. I think someone has given answer. Pandas gives us high performance data structures and having good collection of data analysis methods. Of course, it's a somewhat right answer. But again, you have to deeply look into the problem, because most of the answers I am getting like a generic answer, not a specific answer. I think now I am going to get a specific answer, some specific answer, deeper. That's nice.
Yes.
Hello.
Hello.
Due to the current
Sir, audible, sir?
It's audible. Now I have moved to the hotspot.
Dear participant, if you have any doubts, you can know the things. Dear participant, you can raise your question. Unmute yourself and speak, or you can chat. Put your question in chat box.
Sir, now is it visible, sir?
Yes, sir. Yes, sir. Visible, sir. Yeah.
Okay. Actually, what happened due to current? Just I moved from the I moved from normal mode to the mobile spot.
Yes, sir. Yes. So
No
here
problem.
some network issues.
Yeah. No issue. Okay. Anyhow, many things are there. As I said, again, I proceed. Please, all of you note down. Descriptive statistics will dealing with the mean, median, and all those basic parameters. And there is a concept of re-indexing and again, setting data, missing data, all these things. Tomorrow, practical session. Just to remember, we will see, we'll be seeing. And again, what's really happening in the case of TensorFlow libraries, there is one library called NN libraries, neural network, and Optim is one of the packages which is going to be useful for optimization. Many libraries are available that also we'll be seeing. Okay, no issue. And now, second major domain, just I touch upon, I hope many people may be knowing image processing. Today, with respect to the availability of the time, I touch upon that. Remaining things I proceed tomorrow. And I will be definitely showing 2 or 3 big applications in such a way that everybody can be benefited from the industry side. I'll be showing. You please try to have better benefit. Okay. Again, in the medical image analytics, immediately don't get into the image analytics right away. As I said earlier, any image processing subject, please systematically you study. In the case of image processing, everybody knows that how to enhance the image if it is the image is not clear, and what operations can be done, and what basic methodologies are available for image segmentation and the image classification. And in the case of image enhancements, you have to move with the gray value operations basically. Then how do you apply the range compression? These are the methods. If time permits, today you go through. And after finishing today's evening lecture, don't be free. Whatever I am telling, you please work out from the background. You'll be able to understand many things. One important problem already given, one assignment I have given, one is design and implement a Leonard from the scratch. This is assignment number 1. Assignment number 2, even organizer, please note down, you can send it to the chat. Assignment number 1, design and implement Leonard from the scratch using Python. Even why they should not study today evening. Again, assignment 2, design and implement a backpropagation neural network from the scratch. That is a traditional neural network problem that also they have to implement. Third, implement a few image processing activities using Python, especially using OpenCV. Fourth assignment 4, implement pre-processing activities using Pandas. Implement pre-processing activities using Pandas. I think 4 assignments I have given. Please take it as an exercise. You try to do. Whomsoever has completed by tonight or tomorrow morning, you send it to my email. I mean, by tonight, if you are sending, I can evaluate. I can give you the feedback or output of the exercise. I mean, I can give the feedback of your performance. Okay. So, I think organizer has noted down 4 assignments. Assignment 1, once I repeat, design and implement Leonard and design and backpropagation. Third one, I think Pandas implementation, and another one I told. I think 4 assignments I have given. Okay. Okay. Image processing activities, basic image processing activities using OpenCV. So if they try to encounter with the different basic image processing activities using OpenCV, Pandas, BPN, and Leonard, at least with this background, when they are going to attend my practical session, it will be better for them to ask more questions. For your understanding only, just I have given these 4 assignments. You take it as all these assignments. And by 2 o'clock, if possible, you try to submit it to my email ID. At the end of the session, email ID is there, and I can evaluate tomorrow afternoon. I hope I have my session. That session will make a great impact in terms of the implementation. Okay. Now, again, I think some time I have in my schedule, no problem. I can move with that. So in the case of image enhancements, gray value operations, and without considering the color pixels value and all, RGB consideration, and range compression, histogram equalization with respect to the frequencies of the pixels, okay, or the occurrence of the words occurring in the particular text. You can draw the histogram and all. How do you equalize? And what are the different filters available? And because those who are going to the beginners or intermediate level, please you go through all these things, because immediately in one day you cannot become a very big expert in both the neural networks or image processing or programming frameworks. You have to take much more time to understand. So what are the different linear filters and non-linear filters, how you are going to smoothen it, and median filtering. All these cases are very important for enhancing the image. For the particular image segmentation, actually, the idea is I give you one image, there may be different objects. How do you segment different objects in the particular image? I assume that there are 10 objects in the image. How do you distinguish? Either you move from the top, top left-hand side, top left first pixel to the bottom right last pixel, you can traverse. In terms of the point deduction or line deduction or edge deduction, there are 3 different techniques are there. So what techniques you are using for point deduction, what techniques you are using for line deduction and the edge deduction? Because when the people are coming for the interview, we are asking such basic things only actually. But sometimes the students are not able to supply, then they are not selected. So edge deduction operation, of course, in the college, faculty members are repeatedly saying, please you study, but somehow the students may not be serious. But you attract your students through mathematical concepts. That's first one important big strategy. Second, implementation. So point deduction, line deduction, then edge deduction, and thresholding, region growing algorithm, split merging algorithm. These are the deduction operations and the segmentation strategies you can follow for any image segmentation. And these are some applications I have listed out from the image processing side. Image classification. So tomorrow we will be seeing medical image classification, some kind of analytics, and medical object detection. How the objects are going to, how we are going to detect the objects using deep learning. How we are going to classify the medical images using deep learning. And what we mean by data augmentation, transfer learning. Transfer learning is one of the important strategies where I can use the models straight away from the repository, in the sense that there is no need for me to learn it. There is no need for me to write learn it from the scratch. Sometimes, if your problem is going to be very complex, you can concentrate on the other parts of the problem. That time you can invoke your readily available Learnet API or AlexNet or RestNet, GoogleNet API packages immediately in the application itself. That's what we mean by transfer learning. You are transferring all the readily available immediate deep learning models in the import of the packages itself. I think what sentence I am saying, people will be able to understand. Then neural style transfer is another important issue. It's happening even in the medical image analytics. Then image captioning. Neural style transfer, what is happening? Suppose some set of people, they are laughing, and again some set of people are weeping, and another set of people are wearing some glasses. And can I create a fourth scenario where I can mix all these 3, or 1 and 2, or 2 and 3? That is the way I am transferring my styles from the 1, 2, 3 onto the 4th case. That's what we mean by neural style transfer, then image captioning. So the demo, I think tomorrow we will be seeing. Tomorrow's afternoon, my session will be in this direction. First, I will be spending a few minutes on medical image analytics. Then I will be going to the programming, straight away application. Then I explain TensorFlow programming, Pandas programming, and different packages. And by taking one big application, what is going to happen with respect to hyperparameter tuning, whatever I said earlier, with respect to learning rate scheduling, activation functions, and different regularization, optimization. How do we make changes in the development of the algorithms for analyzing the medical images deeply from the start of the session itself? Okay, I think it will, since Sarah's given 2 hours, I think tomorrow's practical session will make a greater impact. But prior to that, I hope I have given strong foundational basis along with a lot of packages and concepts and all. So all these keywords, when I'm going to say tomorrow, you will be very familiar with that. Okay, thank you, and thanks a lot. If you have any questions, now you can ask before closing the session.
Dear participants, if you have any question, you can raise. Unmute yourself and speak.
And also, while you are going to ask many questions only, we may be able to supply answers from the industrial side. Yeah, please ask more questions.
Hello, sir. Can you hear me?
Yes, sir.
Sir,
Hello.
Yeah. Actually, my question is how to implement this deep learning model like in Python programming service. Any idea where to get information regarding that?
Yeah, that's what tomorrow you are going to see for 2 hours.
Okay.
Tomorrow you are going to see complete programming.
Okay. Fine.
But anyhow, I will be going slowly and steady because there may be mixed audience in terms of the age also. Because normally what happens when the people with a young age may be able to follow. Sometimes the people with for example, 55 or 60, they may be very good in maths and all those things. And sometimes they may not be moving with all the programming and all. Even the people with the senior people will be having more ideas. Younger people should make use of them to write a program. Similarly, you entire group should make your students to write. That is the idea of the whole session. Okay, definitely tomorrow the whole programming session.
Okay.
Okay.
So generally,
Tomorrow, yeah.
Generally, what are all the steps we have to do for like medical images like X-ray, CT, and all, sir? Basic idea. What are all steps we have to follow?
Yeah. That's why even, yeah, what question you're asking is good. Suppose tomorrow I'll be showing one medical image concept. Medical image, suppose X-ray or any images if you are taking, using yeah.
So many people are doing it in MATLAB, right? Nowadays.
No. Actually, I don't want to tell certain things. MATLAB is good. Even certain, I think in the real time IT industries, we people are mainly using Python only, no doubt.
Okay, yeah. If I download some of you say the public data, right?
Yeah.
So I went through some of programming books and all.
Okay.
They have directly retrieved the images from M1 IST like that.
Yeah, correct.
So I have a public data which I downloaded.
Okay.
So I have around for example, 1,500 images.
Okay.
And, at the same time, I can read it, sir. Is it possible by saving it in my system?
Yes. Why not?
What is the procedure, sir? Can you?
Yeah, no problem, sir. You can ask your student to do. If I tell you one thing, that's why we have a big force of students behind us. I give one idea, sir. It is the responsibility of the faculty members to make use of the students greatly. It is in their hands only. Actually, if you see IIT, IISc and all, they know how to make use of their own students. Even international level also. Okay, you need to have ideas. I really appreciate what you have to do. The data set are available. You keep it in the separate folder in your laptop. Again, whatever way you are going to write your application, the application should read that data set through packages like Pandas or sklearn or TensorFlow and all. So there will be one path will be there, URL path. So instead of giving that path, you have to give a path where you are stored in your laptop. That's all. Very simple.
Okay, so that thing when I tried in Google Collaboratory, that one.
Yeah, that's what I am telling. Always Google Collab. I'm very happy. Always when the people are going to download all images from the public data set and keep it in the Google Colab, what's happening? Temporarily information will be available. Next time, after 1 day or 2 days, suppose when you are going to see that the data sets and all, that will be erased. Actually, they are not giving permanent place for you to deal with it, because you are not paying any amount for Colab. It's a free. In the free tier, actually, the question is you are using your Colab in the free tier mode, but if you are paying some amount to the Google Colab, they will be giving the permanent location.
Okay, you are saying like AWS, like
yes. AWS will be giving even a payment model, IBM Cloud, Azure Cloud, Rackspace. So many things are there. All these things, I think people should, students should make use of it. Otherwise, you should invite the people like us Probably we have our own trained employees in our company, separate training unit. And those training unit, if you are going to make use of them, I can send those people to your college for the assisting the placement or some other way. You can utilize. That's very important. We are from the development side. I am the owner of the company. I am from the development side. But we have a separate training unit. So that also you can utilize.
So you people are doing the image-based projects, sir?
Yeah, sir. Develop all, sir. Companies means it's totally different, sir. Whatever I speak, okay, we are everything coming from through the experience. Every day working, sir.
Okay.
That's a great thing. That's why I am saying that we are using clusters. We have our own set of clusters, so we are making use of it.
So
without the experience, pardon?
It's Chennai-based company, sir, or?
Yeah, Chennai-based company.
Okay. So another one doubt, sir. I have another.
Please ask, sir. Please ask.
So when I went through some X-ray images, and I consult with my doctors, they say some compared to COVID, there will be some abnormalities they will be finding based on images like glass opacity,
correct.
fibrosis,
correct.
then the consultation, like that they are giving some medical names.
Yes.
So based on that, how we will train that images, sir? Whether we have to feed these names in our programming for training the images, or I need some basic how to train the images.
That's what I'm telling. Whether your data is going to image data or text data, video data, the whole phenomena is, first of all, you have to pre-process.
Okay.
Then only you can go for modeling.
So pre-processing, you are saying like image enhancement like that, sir?
Yeah, correct. Exactly. Here data pre-processing, image enhancement is coming under the image pre-processing.
Okay.
Correct.
What about segmentation and feature extraction, sir? What about segmentation and feature extraction comes under pre-processing or?
Feature engineering. Yes, pre-processing, everything pre-processing.
Okay.
I tell you, 1 minute, sir. Well, since you are asking this question, the first two, image enhancement, image segmentation, will be coming under the first pre-processing. Image classification only, you are modeling.
Okay.
Okay.
So for example, here you mentioned image enhancement will be having a lot of techniques, right? For enhancement itself.
That's why it's a very big area, sir. Just I throw a lot. For example, I tell you one thing, without studying the complete image processing textbook systematically, different algorithms, there is no point in dealing with one project straight away. That's a great mistake.
After this pre-processing steps only, we can feed that image to pre-trained network, sir.
Yeah, correct. After finishing this pre-processing only, you send those images to the data modeling, where you use the classification or clustering or deep learning as per our convenience.
Okay, you are saying like AlexNet, GoogleNet, like that.
Correct, exactly. AlexNet, GoogleNet, ResNet will be coming after finishing complete image processing. Actually, I tell you 1 minute. In the image processing, the subject itself, other than the image classification and clustering, or whatever you are studying, everything is applicable to pre-processing. The image classification clustering only are corresponding to the modeling. That you keep it in this way.
Okay, sir.
And what you are asking is correct. After finishing, that's why the gray values, histogram, equalization, median filtering, everything coming under the pre-processing. So you please understand, the people who are consuming much more time on the image processing, they are not dealing with the actual classification or clustering. Only pre-processing, that is ETL team, image ETL team. In the company, we have the image computer vision ETL team, NLP ETL team. Again, we have different subdivisions under the AI team.
Okay, sir. Before we will send it to pre-trained network, what will be our input, sir? Whether it's a pixel value?
Yes, absolutely. Everything. Actually, everything must be represented in the pixel value only, but we cannot view all those things. That is a big problem.
Okay.
For example, let me take one image. For example, let it be the dog. The dog image, I need to look at the size of the image. The size is, for example, 254 cross 254 cross depth, weight. Again, I'm saying depth. So depth, weight, I'm saying channeling, color image.
Yes, sir, whether RGB or grayscale.
The grayscale or color image. 255 cross 255 cross 3. 3 means color RGB.
Image, RGB.
So yeah, you have to multiply all these three. 255, 3 means you count something. It may be going beyond 65,000. These 65,000 pixels will be taking 65 input units in the input layer.
Okay, sir.
So that is how we can view. Not possible.
So that thing we have to feed it through programming. Huh?
Yeah, sir. Everything through program, sir.
Okay.
Sir, as far the industry is concerned, coding is going to play a vital role. That's why we give a bigger salary to the people.
Okay.
But unfortunately, most of the students may not be knowing. Only students from only top institutions only enter into such kind of divisions, AI, research and all. It's very difficult. Even development also.
Okay, sir. Actually, I am a research scholar right now, full-time research scholar. I am doing medical image processing in TB, sir. TB
Okay. Very good.
So I went through a lot of literature surveys, sir. But the thing is,
which institution you are pursuing research?
Sir, I am right now in Pondicherry. It's Mahatma Gandhi Medical College and Research Institute. Yeah.
Oh, medical college student or computer science?
No, I am. My background is from engineering. I worked as AP.
Okay.
So after that, I applied for.
Good. Go ahead.
So
Very
I
happy.
tried looking into
Okay.
image. Okay.
Thank you. Really, I'm very happy that I have interacted a lot of faculty members through the session. I think
if possible, I can have some collaboration regarding my project with companies.
that's why I said that I've given the general idea to all the faculty members belonging to different institutions.
Can I know the exact location in Chennai, sir? Your company location? Can I come straight over there?
No. Nowadays, due to the COVID and all employees of our companies are working from their home.
Oh, okay.
Most of the companies, remote mode only, everything is
happening. Can you share your WhatsApp number if possible, sir? I can ping you through.
Yeah, definitely. I give my number, my mail ID. Okay, no problem. Thank you. Thanks a lot.
Okay, sure, sir. Okay, thank you.
Yeah, sir. So, any questions or can I wind up, sir? Organize, sir?
Dear participants, if you have any question, you raise, else we can conclude the session. Any question? Sir will share his mail ID and phone number. If you have any doubts, you can reach her through that mail ID. And
this is the mail ID. This is the mail ID. tsglasses@gmail.com. People can note down the mail ID. Organizer?
yes, sir.
What I have to do, sir, now? Yeah.
Sir, we can conclude the session, sir. Thank you for this wonderful session, sir. Definitely this session will, definitely this session will be useful for the most of the faculties doing the research in this deep learning process, sir. And
you ask the people to attend tomorrow's session. That is very
yes,
important.
sir. Surely, sir. That already you have assigned some assignment for them also.
Yeah. So that is the purpose of the program, sir.
Yes, sir. Sure, sir. So once again, on behalf of Knowledge for Technology, I once again thank you for this wonderful session given by you, sir. Surely, I inform to the participant to that is make ready for the assignment and submit.
Yes. Please, you follow, sir.
Yes, sir. We will follow the things, sir.
And you ask the people to submit those assignments to this email ID.
Yes, sir. We will post.
That is the purpose I have given this email ID.
Okay, sir. Thank you for this wonderful
session. We are coming from product company. We are doing like that. Thanks a lot.
Surely, sir.
Thanks a lot for.
Thanks you, sir. We will meet in the tomorrow's session, sir.
Yes,
thank you, sir.
Thank you.
Thank you, sir.